going to talk about persistence, and let's start about like how do we define persistence and what do I mean when I say persistence. So the term persistence is like fairly well documented actually like in meter and stuff like that, but I think the key thing to realize is that we're talking about a threat actor that already have access, like they have a domain admin or they have admin or they have root or whatever you want to call it. So don't try to think in terms of like, yeah, but you need to have admin to do that, because that is the scenario here, right? If you think that you're a red team and you compromise a target, you want to keep that access somehow. So saying that you need to be root or you need to be like, in the kernel or whatever to do this, then that doesn't make sense, because that's kind of the point. We want to keep the access level that we're currently having. And the same thing is that like a lot of people might think in terms of like, but this isn't even important because you need to like reinstall the system anyways. Like if someone had root access to your server, you need to reinstall it. You can't trust that server. But unfortunately, it's just not that simple, right? You have these like really big enterprises and they can't just reinstall. So we need to try to clean some systems because they can't reinstall and can't just build a new environment just because they've been breached. So persistence is a meter thing. Here you see they have like 22 techniques, which is a good start. Meter is a great resource, but obviously, and I think that's kind of the point of this presentation also, to show that there are way more than these 22 tactics or techniques. So we can't really stop at that. And if we go into like some examples, we have, for example, startup apps. That would be like the easiest example ever, maybe. So in Windows, you have these startup apps that if you want to keep persistent access to a system, even if they like restart the system or your malware crashes or whatever, you can register it as a startup app, and then it's going to start by itself, right? It's not exclusive, obviously, to Windows, but you can, for example, do the same in Linux with etc defaults. So there are some scripts that are going to be sourced every now and then, and you can put your own malware in there. Same thing with cloud. You can obviously have persistence in cloud. So if you take like an enterprise app, for example, in Azure, you can register that, or you can even like take out a secret of an existing enterprise app, which is more stealthy than just registering your own. And the same thing, it doesn't really have to be like a malware per se. It can also be like within an application. So for example, a web shell would also be some kind of persistence. So if we try to like wrap up what persistence is, we're talking about the persistence technique, meaning like the scheduled task or the service or the startup app or whatever the technique is. That's not necessarily the same thing as the payload. So for example, like Cobalt Strike is not a persistence. Cobalt Strike is kind of the payload that is being started by a persistence technique, if that makes sense. And we can have persistence in user context. So if you only compromise a specific user on a system, for example, then you can install persistence within that user profile. But you can also have persistence that covers the entire machine if you're like root on the machine, or it can actually be like persistence over an entire Active Directory domain if you're a domain admin. The way the persistence kicks in or starts or triggers is usually event-based, but it can also be like scheduled. So like a scheduled task is the most obvious example of that. But it can also be manually triggered. So meaning like if you, for example, create a user account on a RDP server, then you need to log in to like trigger that persistence. And same thing with other types of persistence that you need to trigger manually. So it's not only like login persistence we're talking about. Now I'm going to show another example, and bear with me. There's going to be quite a lot of screenshots here, but we're going to get to the point, and I hope you make it all the way with me. This is from a real incident, a persistence, and we're going to see if this is a good or if it's a bad persistence. So there's this scheduled task called reg idle backup. It's a default scheduled task in Windows. This is the legitimate one. This is what it looks like after the persistence is installed. It's quite hard to see the difference, right? So if you look up that CLS ID, you see that it has this property treat as, which points to another CLS ID, which then has a local server defined, which is this PowerShell command, which in these PowerShell command you have an invoke execution with a base64 encoded thingy, which decodes to another registry path, which contains the next step of this payload, which is in a prog ID, which is this PowerShell function. And by the way, that will also be piped to invoke expression. And that finally, after a bunch of obfuscation layers, ends up in a MS-build command line, which points to a file on disk, which is a csproj file, which contains the shellcode that's going to be eventually running the malware. So, is this a good or is it a bad persistence? What would you say? I would say it's a bad persistence. So this is I don't know if it's even cool, but like PowerShell droppers are not really the newest, coolest thing. But I think this is an example of a really, really complex persistence technique that in the threat actor's head felt really, really good. But when you look at it, the final payload is still on disk. So the entire keeping things in the registry is completely doesn't make any sense. And when we talk about the treat as property, for example, it's really bad because it doesn't melt in at all. In my 8 years or something working as a forensic, I've kind of only seen a treat as property once, and this is the case. So if I find that, it's going to stick out really, really much. And in the same way, if you have a big PowerShell command in a registry key, that's not a very usual registry key. So if you can look at all those, you're going to see that this sticks out quite well. So we take another example, if we all agree that that's not a good example. This is actually the most common persistence we see. This is legitimate remote management software. So we talk about AnyDesk, for example, or TeamViewer and this kind of thing. Would you say that that is good or bad persistence? I mean, I think it was a good answer, someone in the crowd. And it depends. It's kind of good, because it's really, really good if it's actually used legitimately. So if there's an organization that uses AnyDesk all over the place legitimately, then it's really, really hard when you look at 1,000 systems to figure out which one is the bad AnyDesk installation, right? And same thing if you have this OT environment where every single vendor installs their own remote management software. And yeah, someone is laughing because that happens all the time, unfortunately. And of course, it's going to be really, really hard if someone jumps in and then installs TeamViewer on one of those servers. It's not going to trigger anything because it's not a malware. It's not going to trigger any antivirus. It's not going to trigger anything. I mean, unless you have a really, really good idea of what software runs in your environment. Plus, the effort compared to the profit is quite good for the threat actor. It's really, really easy to do this. You don't have to maintain some kind of C2 even. You just run well-known software. But of course, if you're if you're NSA, you're probably not going to drop AnyDesk on a server, right? I mean, maybe they are. Who knows? But I think this should be better persistence techniques. So let's look at some examples. But before we do that, let's try to understand how do we work when we try to find persistence, both as detection engineering, but also in terms of incident response. So what are the challenges that we are having, and what are the really, really I used to work as a red teamer, but then I switched to the blue side, and I've been working for a few years with that. And question is if I would go back to being a red teamer, how would I do persistence? And that is kind of the idea with this presentation, and thinking how can we make persistence better? And if we look at the cases where we have failed, or we have done an investigation after another company and found persistence that they missed, I think the most common case is the investigation scope. So unfortunately, a lot of customers say to us that this is an Azure incident. So you get access to Azure and you're going to do an investigation in Azure. But the threat actor don't really care what's Azure and what's on-prem or what's in AWS and so on. But it's kind of hard for us to say to the customer, oh, but we also need to do investigation on 2,000 servers, even though you only find this one thing in Azure. because it's going to be quite expensive for them, and it's kind of hard for us to get the scope right. And I'm sure we are not the only company that have those challenges, right? So that's a problem, and it kind of comes with the same thing with the time limit, that we have a limited time to try to find all of these things. So it would be awesome if we could take like a disk image of every single server and do like a proper forensic investigation of every server. But the problem is when the customer has 500 terabytes of servers, you're not gonna the company is not gonna exist anymore when you're done with that forensic investigation. So you need to have like these shortcuts to do forensic investigations in a big enterprise. And same thing is that when we do investigations, that things might have happened 2 years ago, but the log retention is depends on what system it is, but like 90 days, something like that. On the DC, it's probably like 5 minutes for the security log. And 2 years back is quite difficult to figure out what happened. But when we look at it, we try to look at, if we're only talking about persistence now, in terms of the installation and the dwell and then the activation of the persistence. When we talk about the installation, we get quite a lot of different artifacts. If this is like a Windows service as an example. So we have like prior to the attack, of course, we're going to see that someone is inside the environment and messing around and then installing the service. And when they do install a service, that's going to be logged in several places. You're going to get file records written. You're going to get all these types of things. Then during the dwell time, you have something lying there dormant, which would be like in the registry. You have like in the system hive, for example, you have the service lying there configured and all these things. And then in the activation, when the service runs every now and then, or when the threat actor goes live again, then there's a lot of evidence as well. Then to do this, we have a bunch of tooling. And we have, for example, like sysinternals outruns, and I'm not even going to go through all of this because it's just way too many tools to even go through. Point is that we have a lot of different tooling, and I'm not sure if all of them are great, and it's just way too much work to go through all of this. So let's just ask AI, how do you do this? So I asked GPT 5.5, give me a list of tools and how do you analyze persistence? This is how we're doing investigations these days, right? So it tells me that autoruns is the #1 tool. So let's take a look at autoruns. So here I have autoruns on my domain controller. And if we look at autoruns, it's basically a tool that looks through all different types of startup apps. They call it ASEP, like auto start extension something. And you have things like logon persistence, you have things in Explorer, you have scheduled tasks, services, drivers, and blah, blah, blah. And this is a pretty capable tool. It's not that bad. You run it, you try to find a bunch of things. You have a command line tool as well. This looks all good. Then I start PowerShell on this system, and I pop a calc. So that seems odd. Let's start PowerShell again and see what happened. Popping another calc. OK. That seems like we have persistence on this system, right? So every time an admin starts PowerShell, they're also going to start my malware. In this case, it's just calc. So let's search. Do we have any match for calc? None. Let's also refresh and see that I'm not cheating. And we still don't have any calc. So what super advanced hacking trick do you think I used to bypass this solution that GPT 5.5 said is the best? So I went to Documents. I went to this file. I used this hacking tool called Notepad. And then I wrote calc. Cool, right? So, this is obviously a really, really simple persistence technique. But the point I'm trying to show here is that these tools are as good as what they're looking for. If they're not made to look for PowerShell profile persistence, then they're not going to find that, right? And it's just kind of the same with every tool. It's not just, I'm not trying to bash on autoruns at all. It's just all these tools are going to have their limitations. And there's just so many persistence techniques that it's going to be really, really hard to do forensics this way. And to be fair with the AI, it actually said if you read the full answer, it didn't say only autoruns. It said that if you want to have a decent baseline, you should do autoruns, Velociraptor, Cape, Eric Zimmerman tools, Reg Ripper, Sysmons, Chainsaw, Volatility, OS, blah, 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 blah. And then together, they should have a reasonable baseline. And it's like, yeah, thank you. I'm going to run every forensic tool in the world, and then I'm going to have a reasonable baseline. It's very useful as a forensic investigator to do it that way. If we just stick on autoruns for a moment, so another thing which I think is really important to know with autoruns is that the way it presents the data, it shows you kind of the executable. So if you're using like a lol bin or a DLL sideloading, it's also really, really bad at showing those records. And if we move on, we're going to show some other persistence techniques that this like list of recommended tools wouldn't find necessarily. And I want to be a bit humble a bit about this though, because a lot of these are like quite config dependent. So like what you're going to find if you use Cape in your investigation depends a lot on what plugins you're running. So of course, it depends a lot from case to case. But there's at least no like dedicated plugin or this is documented somehow in a very good way. So let's start with IIS and SharePoint. We did a lot of investigations related to the latest SharePoint exploit. I don't know if many of you saw that. And one of the things that they did that was use this clever trick to maintain persistence. And what they did was that if we look at my SharePoint server here, zoom in just a bit, we see that SharePoint is, you can have it in the cloud and you can have it on-prem. This obviously affected the on-prem version. And in your server, you have this like IIS web server. So if you look under like the normal inet pub, you have your www root, VSS, virtual directories, and then 80, which is some kind of number. I don't even know what it is. And you see that if you open like IIS, you see it's registered as the different sites and so on that you have. So here you have the SharePoint 80 thingy. If you go and browse to that, it looks something like this. So it's nothing weird. And if we look into the web config of this server, we see that it has this machine key configured. So as like in the recent versions, they are encrypting this. Back in the day, it used to be in plain text. And I'm sure that all of you that work with pentest knows about view state deserialization bugs. So basically in IIS, this is nothing new at all. But the way that they are using this is kind of new. So if you steal this view state secret, which is encrypted here, and you decrypt that, and then you use that to sign your own payloads, then you can basically execute code through a deserialization bug. And that is something that, for some reason, Microsoft has decided not to fix. So it's just kind of like an unpatched vulnerability in IIS. So if you leak your machine key, then you have a persistent remote code execution. The only thing you need to do is kind of be able to reach an ASPX file. That's it. However, this one is encrypted here, just because it's, I guess it's because you don't want to have like a local file inclusion kind of situation. However, we are admins now, right? Because this is persistence. We're admin on the SharePoint server, and we want to add persistence to this server. So what do? We steal this secret. And the way we steal it is that the only thing I did was putting this DLL file in the bin folder, and that's it. This is also only temporary for stealing the secret because it's encrypted with like DP API and so on. So I can either do it like and steal those master keys, but the easiest way is just kind of to load something into IIS because there you have the secrets in plain text. So what I do then is that I go into my other machine, and let's zoom, and I have this script which goes to, actually it's on the other server here. So let's go to the right server. So it's portal.hack.ad. And let's see if we had a specific path. But yeah, let's just go here and see what happens. We do the first command, which is the hello, and see if we can reach. And it says that the module responded with hello marker. And the identity running is this one. So then we run the dump command instead, and we see that we dump out these keys in plain text. And this is pretty much all you need to do. When you have this, then you have persistent access to the server. That's pretty much it, right? Now, when I've done this, and that was just like one way of doing it, of course, you can drop an ASPX file, you can steal the machine, you can steal the DPAPI keys and so on to decrypt the machine key. But after this, I just drop this because I don't need it anymore. So there's nothing to find on the system. The only thing the threat actor has is that they know these machine keys. And when they want to get back in, they just trigger the deserialization exploit again, because they have a persistent remote code execution. So that is problematic on SharePoint. And Microsoft added like a machine rotation automation to resolve this. We saw this like widely spread during the some time ago. And yeah, this is one of the solutions. But of course, this is only for like the most recent versions, which of course all organizations run. So it doesn't work for everyone. The other problem is that this kind of reminds me of this demo that my colleague Fabio did back in 2020. Remember that I said that this is really old stuff? So back in 2020, there was this exploit in Exchange, which was that you could bypass authentication, read a config file, extract the machine keys, and execute code. Because yes, Exchange is also IIS, right? So if you have an Exchange server, you can do the same thing. So if we go to my same here, and then instead we point it to my Exchange server, which I've done exactly the same thing. And then I go to like this file because it doesn't have any authentication. So you can visit that anonymously, which is kind of useful if you want to dump out the secrets again. And we have dumped all the secrets, and now we have persistence to the Exchange server as well. And then, of course, you can remove all the like bin files and everything on disk, so there's nothing to find for the forensic investigators. If we look at this in the EDR, so all of these machines that I'm demoing now have Defender running. We can see that when this runs, the only thing that happens is that the module is loaded. That's pretty much everything. And it's unknown, of course, because this is my DLL. There's no like alert or anything like that in the EDR, because I'm only stealing the machine keys that gives the persistent remote code executions forever. But it's kind of a cool technique that we've seen. And of course, there's also like these logs and so on, and some opportunities to find this. But it's kind of problematic in the sense that, you know, think about how many servers run IS. Like your domain controller, they probably run some kind of like IS. Hopefully not. But your like ADCS server, like your certificate services, they definitely run IS. And they definitely have some unauthenticated IIS endpoints, because you need to be able to enroll certificates and stuff like that. So there's so many Windows servers out there running IIS that you can use this to get persistence to. I'm sure you have seen, like if you're a pen tester, you have very likely seen this page that looks like this. This page, right? You see this all over the place internally when you run your internal scans. And you can just think like every server that you have this on, you can just steal the machine key, and then you have persistent access to execute code whenever you want to. It's kind of useful. So that's one way. Another way, which is quite tricky to find and see as a forensic investigator and detection engineer is WSMan plugins. I'm sure you know about like PowerShell remoting. So it's like this protocol to manage Microsoft machines to run PowerShell remotely, as you hear in the name. But what you do is kind of that you run with WinRM, and then PowerShell remoting is kind of a plug-in to WinRM. It's kind of Microsoft's implementation to that open protocol. And the way that that looks is kind of that you have this WSMan or WinRM, and then you have plugins to that. But thing is that we can kind of roll our own plugin. And this is quite useful because it's also very, very hard to see. So if you look at this machine here, I have just kind of updated this. Sorry, I'm going to zoom. So I ran set item WSMan localhost plugin Microsoft Windows file name, and then I pointed it to my own PowerShell plugin. And how did I build my own PowerShell plugin? Well, PowerShell is open source these days, so I downloaded PowerShell, I built PowerShell, and I added my own hooks where I want to execute my custom code. And then I just override the default one, and when it runs, it's going to trigger when someone uses PowerShell remoting towards that machine, if that makes sense. So if I, for example, run here, who am I, pointing to Exchange Mail, oops, then this plugin is going to be loaded on that server. And I, as a threat actor, can't do this to trigger my own persistence, but I'm pretty sure that every now and then, some admin in the organization is going to use PowerShell remoting to the Exchange server, because that's kind of how you manage Exchange servers in a lot of organizations. So when they run invoke command, or they use like enter PS session, for example, will do the same thing, then my persistence will kick in again. Meaning that it's tied to someone unknowingly just kind of using a legitimate service at the machine. So now that I've done this, let's go back to the, well, actually now we're at this one. Let's see if we load, see if we can see what that looked like in the EDR. Yeah, now here we have the previous demo. I guess this might take some time to just load the right data. You can do it. Let's see if we update it like that. Here we go. So we see that who am I is invoked remotely using dcom, which is almost what I did. And here we see that it's created by WinRM. This is like a very descriptive, good thing. And let's see, I mean, what we should see here is basically also my malware loading, because what I guess I haven't showed you, but you see that also here in the POC, I also writing my log here for every time it's executing. So my malware is also running and writing that POC log on the system. But the thing is that it just kind of doesn't show this at all. The only thing that it's showing, and I've tried to really tried to make it find my DLL. But for some reason, Defender doesn't really forward that DLL as like even raw telemetry data. So the only thing I'm finding is the system management automation, which is, for the record, my bad system management automation DLL, but not the PowerShell plugin DLL. And we see that actually that search, I can probably do that search again. If we search for PowerShell plugin, we see that the last event on the server is this morning when I prepared my demo and ran this like set item, something like that. So the actual loading of the DLL is never recorded, which means that we kind of have a place to load a DLL on a Windows system that runs a fully patched like antivirus and EDR, and apparently it's completely silent. So this kind of thing is quite useful. And it's just kind of something that, to be fair with Microsoft, like they can't load every single event to the EDR, right? They need to kind of prioritize and send the telemetry that they think is going to be the best telemetry. But this one is quite interesting because, we don't even see when it writes the poc.log file. The only thing we're seeing here is when I opened and validated that the file exists. So, if I do that same thing again, you see that I'm opening the file here and blah, 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 and so on. Then that is going to pop in because it's like Notepad is loading that file and so on. But the actual creation by the malware of this file is not being recorded as well, which is kind of odd. So I think that still this kind of shows a good example of where we can look at the malware from different perspective. So here we have like, when I did the set item, for example, that would be the installation phase, which I talked about before. So we have if you remember, we have the installation phase, we have the dwell phase, and then we have the activation phase. So obviously the installation phase, I really screwed up here because it's really obvious if someone looks at this. And this is something that gives us a good opportunity to detect the persistence, because we can detect the installation of it. However, the activation and the dwell time is basically invisible in Defender for endpoint. I haven't really tested it in CrowdStrike or any other solution. So, and again, I'm not like bashing on any solution in particular. My point is just kind of that if you're a red teamer or if you're a forensic investigator, you just kind of need to know that you can't just run auto runs, or you can't just look in the EDR and then be sure that you're going to see everything. If we actually we can also search this and see if we get this event. So here, we have we still don't have any load of that file. If we do follow path like this and do all of them, you can see, for example, my demo module being loaded. So we would kind of expect that this kind of event would show up for the other one as well, but for some reason it doesn't. So if we move on, we see my backup screenshots here is not really used because for some reason the internet actually worked, which is great. And let's move on from all of that to something else, which is the network part of the persistence. So when you do some kind of persistence, you need to have a callback in one way or another. You don't necessarily need it if you have a persistence that you can trigger yourself, but then that is kind of like a reversed callback. But in a lot of situations, you're going to have something that calls out every now and then and checks, should I go active again? And I mean, you can do this in a really, really complicated way and try to do DNS tunneling and domain fronting, and there's all these really, really cool techniques to hide your traffic. But the most effective is kind of the simplest, which is to, if the organization is using Azure, then use your C2 in Azure. If the organization is using a lot of AWS, then use AWS. You can set up your own resources in the same hosting provider that the organization is legitimately using, and it's going to be really, really hard for the organization to pinpoint what is bad and what is good, right? It's kind of the same as with the if you're using AnyDesk or these really simple techniques, use what the organization is using, then it's really hard for the organization to find it. So just kind of keep it simple would be my suggestion. If we're looking at this from the Defender perspective, it's just kind of a question of trying to map, if something is talking to, for example, AWS, what should realistically talk there? If we have endpoint telemetry, we can see what process talks to a specific domain, then maybe we can try to filter this down and see that, but this still doesn't really make any sense. But as a red teamer, you can also kind of think in those terms, right? So, for example, if you're using the classic side loading in Google Update, and then you're talking to Google Cloud, then you have a Google binary talking to Google, and it's going to be really, really hard to write some kind of detection for that. An alternative of this, which is quite common, is that you are using a legitimate service. So you're, for example, using, say, Dropbox, and using that as a staging mechanism to upload a command, and then you're reading the command from the other side. But you usually don't really have to do that even, because you can kind of just host your own C2 in a legitimate hosting provider and hide that way. So when it comes to the conclusions, I think that the easy part works, and that's kind of the key thing here. So don't do the overly complex things, because usually, in my perspective, this is kind of what bites the threat actor. We've seen many cases where, for example, the threat actor is time stomping their files, and that time stomping is what caught them. So when you're trying to do this kind of thing to hide, it can usually be counterproductive. And same thing when it comes to clearing the logs is probably the stupidest thing you can do as a threat actor, because that really, really shows that someone was here and is trying to hide. So when you have a threat actor that has cleared the logs, you kind of have their path already, because like I showed in the picture before, the event log is just kind of one evidence, and just clearing one log is usually not enough to hide anything. You're just kind of showing that you were there. When it comes to the persistence in general, when it's a good persistence technique, you kind of have a good installation method, so you can install it without leaving too many traces from the actual installation. And then the dwell needs to be silent as well, and of course also the activation. But when it comes to the activation, it's usually tied to how well your C2 is running, your specific payload, so that whatever rat you're running. Meter tactic, if you're a defender, it's a really good start. And to be honest, we just kind of need to start somewhere. So start with Mitre, because it's a quite good coverage of everything. But of course, if you're a red teamer, you should also start with Mitre and then don't do anything that is written in Mitre, because that's what everyone is following, right? So just kind of figure out what is in there, and if your detection or if your technique is described in there, then move on to something else. Finally, I think it's important that we, as red teamers, adapt to the target, and as defenders, can't just if something is talking to Microsoft, it must be good, because it's just not that simple, right? So we need to kind of look at it from a network perspective and endpoint perspective, and use the legitimate tools that they have in the environment, and use the legitimate network services that they have, and make sure that you melt into whatever already exists. One thing to end with, and I think it's back to the point with that easy things work. You might have noticed that I didn't talk about rootkits or bootkits and these kind of super cool things. And the simple reason is that we very, very rarely see them, because like I've said 15 times now, the easy things work. So why would you bother developing these super advanced backdoors when no one is even looking for your PowerShell profile script, right? Because a lot of organizations, they don't even look for persistence to begin with. They roll back backups, and then they roll back backups with the threat actors C2 in them as they are, just untouched. And they're like, great, we're back from the ransomware now, right? So I mean, if we just start looking for this, I think that would be a very, very, very good win. And I think it's kind of a joint thing that all of us needs to figure out somehow to, try to look at this. Because it's not great if we in our society have all these backdoors and sleeper cells, whatever you want to call them. So let's try together to find them. And thank you all for staying and watching this final presentation. And see you next year.
Woo! Woo! Thank you very, very much for that nice talk. Now I'm back. So a final round of question. Who wanted to ask the last question? Raise of hand. Do we have anyone?
Anyone in the crowd? Can I see a hand? Oh, we got one right here.
Nice.
Have you found any backdoors on your personal machine?
That is not yours.
No, then it's not mine anymore, right? That's the joke. I mean, I wouldn't if I had. I wouldn't tell you, right?
True. Anyone else? No?
Seems to be about it.
Cool. You can just grab Alexander afterwards. You will be around for a little bit.
Thank you again so much.
Thank you.